The purpose of this video is to check your work and get a deeper understanding about the water cycle from the website exploration. So the website you were using looked like this when you were clicking around. And so the first word that you wanted to define was evaporation. And so you search for it and you can see evaporation is here, right? And the going up. And so our definition for evaporation is that it's when water goes from a liquid to a gas and it does need heating. And so the key question that went with it was, what is water vapor in the air called? And we call that humidity. So if we think it through, what season is it more humid? Well, that's generally summer, and that makes sense because we have higher temperatures to drive that evaporation process. Also notice something in this little diagram I put in here, that you can see the water drops the water molecules are spreading out during evaporation, moving faster, spreading out. That's important for our next one, actually. Okay, so our second term was condensation, and you can find it way up here. Condensation is the opposite of evaporation. And so condensation then means this, not a liquid to a gas, but when water goes from a vapor, a gas back to a liquid, and it needs cooling. And so if you think about this, as water rises up into the atmosphere, the temperatures are actually cooler. We know that because we think of, well, snow-capped mountains, right? So as you get this rising humidity, rising water vapor, the molecules start to physically condense, which means pack together. And literally, the molecules are going from a gas back to a liquid. Now, this is a super important question, and one that honestly students historically have struggled with. Clouds are not made directly from evaporation. They're made from condensation. And think this through. What comes out of clouds? Well, rain and snow. Not a vapor, right? They're made of either liquid or ice if they're high enough elevation. So right here, this shows the whole process of cloud formation. So you're seeing an ocean. So heating makes the liquid go to a gas. And then this part that says particulate matter, there's actually ancient volcanic ash all over the upper parts of our atmosphere. And that's what, just like when you take a hot shower, your water will condense on your mirror. The particulate matter up in the atmosphere is what the clouds condense around. So anyway, as you get higher in the atmosphere, you get cooling, and the water goes from a vapor back to a liquid, and eventually it gathers and becomes so saturated or full that it leads to precipitation. So evaporation, again, is liquid to a gas. Condensation is the opposite. It is gas to a liquid, and it directly forms clouds. So what about precipitation? So we look here, we see precipitation coming out of clouds, and this one is more commonly understood by students, but it's just falling water from clouds. And so there was a comparison made on this website. If the atmosphere is like a superhighway, like Route 16, say, what's precipitation like? And it's really like the exit ramp. So it's returning water to Earth's surface in order for the whole process of cloud formation to happen again. Now, this was a little interesting diagram I found. So if you notice, these higher elevation clouds, it always starts as frozen precipitation. But if it's warm enough near the surface, we get rain, right? If the air is warm near the surface, but the surface is cold, we get freezing rain, which is, real bad for travel. And then here you can see sleet. The snow melts and then refreezes as it travels. And snow, of course, is when the surface and the upper atmosphere is all equally cold. So if you're curious about those different forms of falling water, remember, snow is still water. Okay, so now we get to our next one, which is runoff. And these look like some of the water drops that are having the best time. You notice they look like they're on a slide on a playground. And runoff is honestly what it sounds like. It's water running off the land. So a better way to say it is water moving downhill due to gravity. And so if you look right here, it doesn't look like a severely sloped field, but there has to be some slope to it because we see the water running off after a heavy rain or a heavy amount of snow melt. And so runoff actually recharges our groundwater. So most of us have well water out here, and so we are actually drinking and bathing in, pumping water from the ground. Some of this runoff doesn't make it to streams. Some of it actually soaks to the ground to recharge our groundwater. Okay, so next up we have a spring. And so actually the spring kind of got cut off. No, it didn't. Here it is. So you can see the spring is down here in the ground, and look what's happening. that little water drops coming right out of the ground. And so a spring is when groundwater meets an opening at the surface. And so if you check out this picture, this is an example of spring water. So literally that water would be flowing within rocks underground. And right here, you have this exit. Now, in your mind, I want you to take this diagram and turn it towards you. Okay, so can you kind of see the situation underground? These fancy words, impervious, impervious. The impervious rocks mean they don't hold water very well. The pervious, can you see those are more coarse-grained, like the big chunks, and so water can flow underground through those. Well, if you have the right erosion pattern, like right here, there's an exit, and that's how we get spring water. Many of you, including myself, have springs on our property. It's very common here. So why don't springs exist everywhere? Because the rock needs to be full of cracks. It needs to be able to have water flow within it. Okay, so again, a spring is right here. It's when groundwater is meeting the surface. Okay, now this word is fancier. Okay, so infiltration is the one that actually got cut off, I believe. So these little drops are infiltrating. So I think of it like this. Infiltration means water soaking into the ground. So what if during the Civil War, the Union line infiltrated the Confederate line? Well, that means it's getting into the Confederate line. That's all infiltration is, water soaking into the ground. Now, this is an interesting little note, though. How can groundwater be recharged if it rains hundreds of miles away? And did you realize that water can sometimes flow sideways underground? So it doesn't necessarily have to rain in your location for your groundwater to get replenished. Infiltrate again, water soaking into the ground. Okay, now this one is not perfectly labeled, but down here where you see the groundwater, this would be an example of an aquifer. Say it again here, ready? Aquifer. Sometimes people call it aquifer. For some reason, it's aquifer. And aquifer is kind of weird because all of these words refer to water. This does not. An aquifer is a rock. Okay, listen again to that. An aquifer is a rock, and it's a rock that has the ability to store water. So why doesn't groundwater exist super deep, right? Like, so oil and gas wells, they have to drill pretty deep around here, like thousands of feet, water, hundreds of feet. And here's the reason. First of all, the rocks get too dense as you go deeper and deeper from the pressure. And so any water would have been squeezed out of there. But this is really, I think, the most interesting one. If you go down too far, you start to get the heat of the Earth's inner heat, and it will actually boil your groundwater. So that's why our water wells are close to the surface. Now, this is an interesting map. So this is a map of the U.S. and all the aquifers. So what do I mean by that? Those are places in the U.S. where our rocks have the ability to hold water. And so the only places that don't are the places that you see that are white. They have the wrong geology underground. But look at Ohio. We can barely see us, right? So that's why groundwater, well water, is such a common source here. And you can see, interestingly, even places that are a desert still have the right rocks underground to hold water. And we know that climates change over time. So those places, at least at this point, still have aquifers that they can draw from. Okay, and then the final term is probably the most difficult one of all, and it is transpiration. And I believe you had to click on evapotranspiration, which is not on this exact image, but these little drops here that are having the picnic on the tree are about to experience transpiration. So transpiration is a fancy word that means evaporation from leaves. And so what's happening in the bag, see this bag is, tied at the end. You can actually see water evaporating from the leaves and then condensing back to a liquid. And that's why it looks kind of foggy on the bag. So this is proof that evaporation happens. And then I thought you might be interested to see this. So this is actually the underside of a leaf. And you may have learned this last year when you were studying photosynthesis, that there are holes in the bottom of leaves, microscopic holes called stomata. And these are guard cells on the side of the stomata, and they are used for gas exchange and like for carbon dioxide and oxygen, but also for water to leave the leaf and evaporate. And that's important because as the leaf heats up, if the water didn't have a place to go, the leaf would explode as it turns to a gas. So that's actually a microscope view of the cells that are involved in that. Okay, so make sure you've checked all your work and that you're becoming an expert on the water cycle.